Well, as of today, we're at the end of the original 2 weeks that Governor Wolf had declared, so this should have been a math lesson for the Friday the 27th. This would be the last paper in your original packet. So we're looking at absolute value is what this paper is titled. So two things that you should need to know for number one and number two on the paper once you locate your absolute value paper is what the absolute value of a number is. It's just the distance of a number from zero. And what it always is for number two, it always turns back as a positive number. So if you're asked to do the absolute value of a positive number, absolute value of positive 6 is just 6. The absolute value of negative 6 is also 6, because both of those numbers, their distance from 0 is 6. The only number that's not going to give you back a positive would be 0. The absolute value of 0 is 0, and technically 0 is not a positive number, it's in a club by itself. But for every other number other than 0 in the universe, you're thrown a number, you throw back a positive number of the same size to just measure how far it is from 0. These bars are the punctuation mark symbols for math that mean you're doing an absolute value. In some of these upcoming problems I'm about to do, the bars act like parentheses as well. You have to do the problem that's in them first before you acknowledge the existence of the bars. So these two questions are two different questions. Even though they both have 5 minus 7 different ways, the way the bars have been arranged is going to create two different problems. It might still give you the same answer, but you have to go through two different thoughts at times. So for this problem, since the subtract is in the bars, you'd have to do the subtracting first. 5 minus 7 makes you think about negative 2 for a moment. Then acknowledge that the bars are there, and we're going to turn negative 2, which would be in there where my hand is, negative 2 turns into a positive 2. If I go to tackle this problem, the bars are surrounding individual numbers, so you take this on differently. You would just do this part and think 5. You would then do that part and think 7. Then the subtracting is happening last because it wasn't inside the bars like being inside parentheses. We just wait on the minus. Take the 5 minus the 7, and that turned out to be negative 2. If I did a small change on this, if this were a negative number, that would have accomplished no change because the bars would still zap this to 5. You'd still go 5 minus 7, we'd get the same answer. If I did this, that would do nothing. The bars would zap this into 5, they'd zap that into 7, and it's still 5 minus 7. We'd still get negative 2 even with all those changes. I'm going to take those back away. If I change the sign here, the subtracting now would get us in the 12 family. If this were a negative, negative 5 minus 7, we'd be thinking negative 12. The answer would then be 12. There are things like that that could happen. Adding version of this. Okay, so again, if the adding is in the bars, you have to do the adding first. This problem, the adding is not in the bars, so do the adding later. If we do the adding first in here, when a negative adds a positive, it depends on the bigger number, and we subtract them, we'd be thinking in here about a 3. When the bars try to zap the 3, it's still just 3. For these, we do the bars first, save the add for later. So that would be a positive 2 when we do the bars. This would be a positive 5 when we do the bars. 2s and 5s would make a 7. If I change that, it's still 7. It's still 2 plus 5. If I threw a negative in here, it's still 2 plus 5. It's still 7. It's just the way those have to be. Here's a subtract variety. We have this in the bars. We have to do it first, bars for later. This would subtract to make negative 5. It's kind of like it's negative 2 degrees outside. You subtract 3 more degrees. We're thinking negative 5. The bars make it 5. This, the subtract, is not in the bars, so we do the bars first. The bars would make this 2. It would make this 3. Stay 3. And then subtract. 2 minus 3, that's negative 1. Multiply problem. The multiply would happen later because it's not in the bars. Zap this into 2, zap that into 3, 2 times 3, that's 6, and that's basically, now I have a twist to throw on when I look at the paper, but we're most of the way done. A quick peek at the paper reminds me that on some of these problems, I also threw a negative sign out before the problem even started. So what that would do is take the answer that we had, but switch it. So if I did that up here, we would do the whole same process. We'd have thought all about the 3. We would not have even looked at this until the very, very, very end of the problem. And then I'd have thrown that on there. If I do that on a problem like this, that will only affect this one part. Okay? I just turned this 5 into a negative 5 to subtract 7 more. The bar is still making this a 7. The bar is still making this a 5. This switches it, so it's negative 5 minus 7, which would take us to negative 12. That's kind of like it's negative 5 degrees outside, and you subtract 7 more degrees, we'd be down to negative 12. If I did that here, it would only change this piece. Okay. This piece is 2, but that makes it negative. This piece is still 5. If I add negative 2, positive 5, it depends on the bigger one, and we subtract, that would be a 3. If I did that there, this is still a 3, this is still subtracting, this is still a 2 for a minute, but that makes it a negative 2. Negative 2 minus 3, that's that same kind of subtracting to get negative 5. It's already cold, below 0, 2. Take away 3 more degrees, we're down to negative 5. If I did that here, it only changes that 1. The bars had us earlier at 2, now that's negative, it's still multiply, it's still 3. Multiply idea with 1 of each is a negative. Quick skim of the sheet to make sure now that you're covered for everything, and I do believe that you are. If you have any questions on this or any other lesson you've done to this point, send me an email, I'll try to work it out.